Hello, my name's Sean Hudson. I'm a lecturer at the University of Huddersfield in the UK, and I'm going to present some work from the final study of my PhD, and that work looked at the effect of step width control on load carriage economy. Before I move on with my presentation, I would like to thank my co-authors, particularly Benedict van Wansiel from the Human Movement Biomechanics Research Group at KU Leuven in Belgium. Without her collaboration, this research would not have been possible, so thank you. So to start with some background on the research area, improved energy expenditure with load carriage have been reported across different methods. An early study by Malloy and colleagues in 1986 found that African women with several years of head loading experience were able to carry up to 20% of their body mass with no increase in oxygen consumption above that required for unloaded walking, which is a remarkable finding. In 2000, Lloyd and Cook showed that carrying a heavy load evenly distributed between the back and front of the torso required a lower oxygen consumption of between 6 to 9% compared to the same heavy load carried on the back. And then in 2004, Abe and colleagues found that carrying a light load on the back of around 15% body mass was more economical than carrying heavier loads on the back. So these energy saving phenomena have been reported across different methods of load carriage, but the determinants remain unclear, and understanding the determinants would be beneficial in terms of being able to improve load carriage performance, particularly for individuals that are required to carry load as part of their occupation, such as in the military and emergency services. So one walking gait factor that has been shown to influence energy expenditure for unloaded walking is step width. Donnellan and colleagues found that an individual's most economical step width was their preferred when walking unloaded. And if we look at the figure on the right of the slide, this was taken from Donnellan paper, it shows that the preferred step width, which I circled, was associated with the lowest energy expenditure, and narrower step widths or wider step widths then increased the cost of transport. So that made us think how load carriage with different methods might alter step width away from an individual's preferred unloaded walking width, and whether or not that might influence an individual's load carriage economy. So the aim of this study was to evaluate changes in step width and economy when carrying loads on the head, on the back, or evenly distributed between the front and back of the torso, and then look at how any changes in step width with these methods might then influence load carriage economy. So the research took place at KU Leuven in Belgium. We recruited 15 participants, 10 males and 5 females, and each participant took part in 3 different trials, which differed by the method of load carriage. So as you can see on the slide, participants carried load on the head, on the back, and evenly distributed between the back and front of the torso. And with each method, they walked unloaded and with 3, 12, and 20 kilograms. And they did this without us controlling step width. So this was their preferred step width for each of those conditions. We measured walking for 4 minutes under each condition in order to measure economy, with 2 minutes rest in between. And then after a further rest period, we asked them to walk again with each load carriage condition, but this time we controlled step width to their preferred unloaded walking step width. And we controlled step width by marking out what their preferred unloaded width was on the treadmill, as you can see by the image on the slide. And then we placed a monitor in front of the participant and asked them to align markers placed on their heel with the markers at the back of the treadmill. And we measured step width based on the distance between the markers on their heels using a motion capture system. Just some further details on the methods. So we controlled walking speed to 3 kilometers an hour, and that's because the previous studies that I showed on the first slide that have found an energy saving phenomena for different methods have all done so at 3 kilometers an hour. So we use that speed as well. And we measured relative load carriage economy using the extra load index, which includes a measure of oxygen consumption when walking unloaded in the measure of load carriage economy, and that equation can be seen on the slide there. Okay, so let's move on to look at the results. So if we look at the table on the left of the slide, you can see the step width for each load carriage condition when walking without any control. And step width significantly increased as the mass of the load increased with the head loading method, but did not change with back loading or back front loading. Then if we look at the figure on the right hand side, you can see the economy associated with each load carriage condition for preferred step width. And you can see that head loading was associated with an increase in ELI, which signifies a worse economy. So an ELI value of 1 would show that the energy expenditure increased in proportion to the increase in the mass of the load. So a worse economy or increased energy expenditure for head loading without inexperienced head loaders, so it might be expected, compared to both back loading and back front loading. When we then controlled step width, there was no difference in step width between the conditions, as you might expect. But if we look at the figure, there was still a significant difference between methods, with head loading still associated with a significant increase in ELI or a significantly worse economy compared to the other 2 load carriage methods. And there was no difference in ELI values between the controlled step width condition and the preferred step width condition. So altering step width did not alter economy for any of the methods. So we concluded that based on the data that we've presented here, that a worse load carriage economy for head loading compared to back and back front loading is not explained by load carriage induced changes in step width from an individual's preferred and loaded width when walking on an even flat terrain. It is likely, however, that the alterations in step width that were induced by load carriage in our study might not be large enough to cause alterations in load carriage economy. In the paper by Donnellan, looking at unloaded walking, they found that as step width increased away from an individual's preferred and loaded, that energy expenditure increased. So it might be that with heavier loads, faster walking speeds, or an even terrain, there might be different results, and you might see some influence of step width on economy. Here are some references from the slides that I've presented. Thank you for listening. If you have any questions or would like to discuss anything that I've mentioned in the presentation, then please feel free to contact me via Twitter or via email. Thank you.